Hello everyone, welcome to a personalized episode of Enlighten Me. Today we delve into the integration of artificial general intelligence in society, explore how leading tech companies measure engineering productivity, and examine the impact of design-driven development in software creation. Join us for insights into these evolving technological landscapes. What will the advent of artificial general intelligence, AGI, look like, and how will society and the economy adapt to it? This is a question that sparks a wide range of responses, from hopeful optimism to fearful doom. However, to navigate past the abstract and into a more concrete understanding, let's delve into the analogy of self-driving technology as a forerunner, shedding light on the societal dynamics of increasing automation and offering a glimpse into the future of AGI. Self-driving technology, a marvel of modern automation, stands as a vivid early case study for AGI's societal impact. Its development didn't happen overnight, but was the result of gradual advancements, starting with partial automation, where AI-assisted systems like Level 2 driver assists in cars collaborated with humans. These systems handled low-level driving details, such as parking, yet required human oversight for complex decisions. This mirrors the current state of tool AIs in various sectors, such as GitHub Copilot for code completion or GPT-4 for writing functions, representing a collaborative synergy between humans and AI, signifying the stepping stones towards full automation. Full automation, as epitomized by Waymo's driverless cars in San Francisco, showcases a leap where AI operates independently, offering a glimpse into AGI's potential. The transition from human-driven Ubers to autonomous Waymos illustrates not just a technological marvel, but a shift in societal norms and preferences. However, despite the availability of such technology, the mixed economy of full automation reveals a preference diversity. Some people still opt for human drivers, either out of ignorance of the automated option, distrust in the technology, or a simple preference for human interaction. This highlights a critical aspect of AGI's integration into society. It will be gradual, met with varying degrees of acceptance and resistance, shaped by trust, regulation, and infrastructural readiness. The economic implications of this shift are profound yet nuanced. While autonomous driving technology, akin to AGI, may displace certain jobs, it also creates new roles and industries, from data labeling for training neural networks to remote vehicle support and maintenance. The transformation is less about job deletion and more about job refactoring, with the overall impact on employment being a slow, evolving process rather than an abrupt change. This transition underscores the importance of adaptability and continual learning in the workforce to thrive alongside advancing automation. The competitive landscape within the self-driving domain, with companies like Waymo, Cruise, Zoox, and Tesla, reflects the broader dynamics that will likely characterize the AGI era. The consolidation of the industry, the push towards global scalability, and the strategic approaches to achieving full autonomy underscore the complexities of bringing such technologies to market. These dynamics hint at the potential pathways and challenges in the wider adoption of AGI across various sectors. Society's reaction to the introduction of self-driving technology, ranging from indifference and curiosity to resistance, offers valuable insights into how AGI might be received. While the initial introduction may spark wonder and skepticism, the gradual normalization of such technologies indicates a potential path for AGI's integration into everyday life. The mixed reactions underscore the importance of managing public perception, ensuring safety and reliability, and addressing ethical considerations to foster acceptance and trust in AGI. In conclusion, reflecting on the journey of self-driving technology provides a compelling analogy for envisioning the future of AGI. It suggests a gradual, complex process of technological adoption and societal adaptation, marked by innovation, regulation, and evolving human-machine collaboration. And now, pivot our discussion towards learn entrepreneurship. What if we could pinpoint the secret sauce behind engineering productivity? What makes a developer truly productive? That's the main question we'll explore today, diving into the insights and methods companies use to measure and enhance the productivity of their engineering teams. This isn't just an academic exercise, it's a quest for a practical blueprint to maximize efficiency and satisfaction in a modern tech landscape. Now let's talk about Google, a titan in tech renowned for its innovative approach to pretty much everything. You might assume that Google's developer intelligence team employs some arcane metrics accessible only to them, but that's not entirely the case. Their philosophy is something any organization, regardless of size, can learn from. Google doesn't rely on one metric to gauge productivity. Instead, they assess speed, ease, and quality, understanding that these dimensions are interrelated and sometimes at odds with each other. This multifaceted approach allows them to balance trade-offs and get a comprehensive view of productivity. For example, when scrutinizing their code review process, Google measures how fast reviews are completed, speed, how complex the process is for developers, ease, and the feedback quality. They combine qualitative and quantitative data, blending user perceptions with hard data and deep dive studies to ensure the metrics align with developers' real experiences. LinkedIn, with its Developer Insights team, mirrors this sophisticated approach. They use quarterly surveys, real-time feedback systems, and system-based metrics to capture the developer experience. One might wonder about the specific metrics LinkedIn values. They track a range of metrics, from developer net user satisfaction to build time and code reviewer response time. Interestingly, they also use Winsorized means to account for improvements in outlier metrics, giving a more accurate picture of changes in performance. Now, let's shift gears to Peloton, a fitness giant with a tech heart. Peloton's tech enablement and developer experience team leads their productivity measurement efforts, emphasizing the human element in the engineering process. They measure engagement, velocity, quality, and stability, using semi-annual surveys to gather comprehensive data while minimizing the survey fatigue that can skew results. Then there are the scale-ups like Notion, Postman, and Intercom, which focus on movable metrics that their teams can directly influence. These companies measure ease of delivery, developer engagement, time loss, and other metrics that reflect the ease and efficiency of delivering software. They understand that making small, impactful changes can lead to significant improvements in productivity. From the insights of these 17 tech companies, some fascinating trends have emerged. One might expect widespread adoption of DORA and space metrics, yet only Microsoft fully embraced one of these frameworks. More commonly, companies use elements of these frameworks as part of a broader strategy. Additionally, there's a strong focus on qualitative metrics across the industry, a shift from a quantitative-only mindset that might have dominated just 5 years ago. Another surprise is the emphasis placed on focus time. Research supports the idea that undisturbed deep work is crucial for developer productivity, and companies are taking note. For instance, Uber measures weekly focus time per engineer, recognizing the correlation between uninterrupted work and high productivity. Each company has unique metrics, too. DoorDash tracks adoption rate, Uber notes the frequency of design docs generated by engineers, and Etsy measures experiment velocity to assess learning and customer focus. These unique metrics are part of a broader, holistic measurement strategy that reflects each company's individual priorities and culture. So, how should your company select metrics to measure? The Goals, Signals, Metrics framework is an excellent starting point. It encourages defining clear goals and identifying the signals that indicate those goals have been met before choosing metrics to track progress. It's all about aligning your metrics with your mission. For developer productivity teams, it's vital to pick metrics that reflect and support their charter. Whether the goal is to make development fast and easy or to streamline the engineering experience, the chosen metrics should directly capture these objectives. Operational metrics tied to specific projects or OKRs can further refine this alignment. Engineering leaders, when faced with requests for metrics from CEOs or leadership teams, should reframe the problem. It's not just about finding the perfect productivity metrics, but rather demonstrating stewardship of engineering investment. This involves reporting on business impact, system performance, and engineering effectiveness, using a combination of the insights we've discussed. Now let's explore how prioritizing design in software development, as demonstrated by FitStride, impacts product success and user satisfaction. Design-driven development is a paradigm shift that places design at the forefront of software creation. Rather than treating design as a secondary concern, DDD recognizes its pivotal role in shaping the direction and functionality of software products. The evolution from the rigid waterfall model to the adaptive agile framework highlighted the need for rapid iterations and user-centric solutions. DDD harnesses the power of design to guide these iterations, ensuring that products not only function but also deeply resonate with end users. To understand DDD, it's crucial to grasp how it influences the entire software development lifecycle. Developers receive a clear roadmap from the design team early on. This roadmap informs the creation of new features, architectural decisions, and even the code itself. The result? Products that align seamlessly with the preferences of the target audience, resulting in fewer revisions, a faster time to market, and a more streamlined development process. Imagine a fictional startup, FitStride, that aims to revolutionize fitness tracking for urban walkers. The traditional approach might involve developers creating a step-tracking algorithm and building a basic user interface around it. However, this approach is based on assumptions about user preferences and needs, which can lead to revisions and redesigns down the road. FitStride takes a design-driven development approach. They begin with user research, engaging directly with users through interviews, surveys, and questionnaires. This research goes beyond just asking what users want. It seeks to understand their pain points, needs, and aspirations. The data collected is then synthesized into user personas, which aren't merely fictional characters, but are informed by real user feedback. These personas help the team visualize who they're designing for, ensuring a clear user-focused direction. Additionally, designers create journey maps, using these personas to visualize every user interaction. This exercise helps pinpoint areas of friction and moments of delight, offering a holistic view of the user experience. Following this extensive research, FitStride narrows down their insights during the requirement gathering phase, prioritizing user needs. Collaboration between developers, designers, and business stakeholders is crucial to ensure alignment with user needs and business objectives. The team creates a feature list, focusing on those features that genuinely enhance the user experience. The design and ideation phase is where the magic happens. Cross-functional teams collaborate to brainstorm solutions, drawing on the input of team members with diverse skill sets and organizational goals. Designers create wireframes to decide navigation and architecture, while mock-ups refine UI design elements, including buttons, menus, colors, and fonts. To prototype and test designs, designers need the right tools. This is where technology like UXPins Merge comes into play. It allows designers to create interactive prototypes that accurately resemble the final product, facilitating meaningful user feedback based on realistic interactions. Handing off designs to developers is a crucial step. Effective communication ensures that developers understand the design's intent, resulting in a final product that aligns with user needs. Establishing a common design system and component libraries ensures uniformity across the product. The iterative feedback loop phase involves real-world testing and A/B testing to refine the design based on user interaction and choices. The journey doesn't stop at launch. Products continue to evolve based on user feedback and market demands. Strategies for release and ongoing development depend on user feedback and business goals, ensuring that the product continually aligns with user needs. While DDD holds the promise of creating user-centric products, it's not without its challenges. Balancing aesthetics with utility, ensuring seamless designer-developer handoffs, avoiding scope creep while meeting user needs, and overcoming organizational silos are just some of the hurdles that teams must navigate. Thanks for tuning in to today's episode of Innovation Pulse. If you enjoyed our insights and are eager to learn more, the Enlight Me app is just a tap away. Expand your knowledge with personalized content on over 20 diverse topics, from crypto to health and beyond, all curated to fit your interests. Download the Enlight Me app now at the Apple Store or Google Play, or visit the enlightme.ai website. Stay curious, stay enlightened.